Welcome student to online classes of mathematics for class 8. In this video we are going to study the chapter number 5, which is data handling of NCERT textbook, and we will be covering the exercise 5.3. This is session number 4 for this particular chapter. Myself Deepak Gautam, TT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. The next topic that we are going to study is the chances and the probability. Okay, the next and the last topic of this chapter is chance and the probability. In this we have certain terms. So first we will discuss those terms, then we'll move to the exercise 5.3. So first thing that we have to discuss here is a random experiment. A random experiment is an experiment whose result is unknown or cannot be controlled. So when we are to perform an experiment whose result is unknown or we cannot control the result is termed as the random experiment. For example, if we toss a coin, we cannot control it to either fall on heads or tail. So such experiment are called random experiment. Similarly, if we are to throw a die, okay, so result can be either a number from 1 to 6. We cannot control the result. So all such experiment are called random experiment. So those experiment whose result cannot be controlled are called random experiment. Okay, moving ahead to the next one, we have next is outcome. Outcome is simply the possible result of an event. Okay, it says the possible result of an random experiment are known as outcome. Okay, so when we perform an experiment, like I said, tossing of one coin, so when one coin is tossed, the possible outcomes are heads and or tail. Okay, so when we toss one coin, it can either fall on a head or a tail. Okay, so these both head and tail are the outcome of this event. That event here is, or the experiment here is, tossing of one coin. Okay, so when one coin is tossed, the possible result or the outcome is either a head or tail. Okay, similarly, if we look at the second example, when we are to throw a die, okay, the possible outcome can be number 1 2 3 4 5 1 6. So whenever we throw a die, the possible number that it can show are from number 1 to 6. So all these are called the outcome of this experiment. Okay, the experiment performed here is throwing of a die. Possible outcomes are, it can show any number from 1 to 6. Similarly, in the case of coin, when the one coin is tossed, the possible result can be either a head or tail. So both are called the outcome of this event or the experiment. Okay, simply the outcomes are the possible result. So whenever we toss a coin, the result can be either a head or tail. So both are the outcome of that event. Okay, similarly in the case of die, the outcomes are from number 1 to 6. Okay, then next we have the equally likely outcome. Okay, this simply is when we toss a one coin. Suppose if we could toss one coin, the possible result can be the head or a tail. Okay, so if we toss 10 coin, if we toss a coin 10 times, okay, here the one coin is tossed one time. If we toss one coin 10 times, okay, we are again tossing one coin 10 times. So it can show any number. Suppose it shows fall on heads 6 times and on tail 4 times. Okay, suppose if we toss the same coin 100 times, then you will see that it can be like, say, heads can come around 51 times and tail 49 times. Okay, I'm just assuming its number, there's not a, but when you increase the size of the experiment, that means the coin is tossed, suppose now coin is tossed 1000 times, you will see that the result of the number of toss will be coming close to each other. That means you will see that the both will be likely to be equal. Let's say this is 51, this is 49, which are very close. Okay, so similarly, if the coin is tossed, let's say it shows 505 times heads or 495 times tails. Okay, so when you increase the number of times a coin is tossed, you will find that the number of time heads appear or number of tail appears will be coming close to each other. Okay, so that's it, that is the equally likely outcome. So which is when each of the outcome have same chances of occurring, then such outcome are termed as equally likely outcome. Okay, when we toss a coin, so the chances of getting a head or a tail will be head or tail, getting a head or tail is equal. Okay, for example, when a coin is tossed 100 times, as the number of tosses increases, the chances of getting a head or a tail will become almost equals to one another. Okay, so when as the number of time the coin is tossed, the chance of getting a heads or a tail will be almost equal to each other. Okay, so such events are called equally likely outcome. Okay, I hope it's clear to you. So whenever we are doing a perform an experiment, if we perform that experiment multiple number of times, you will find that the all results have the equal chances of occurring. Okay, so this is called equally likely outcome. Okay, next we have linking chances to probability. So we can link the chance to a probability. Okay, the probability and the chance can be related to each other as follows. We have this formula to calculate the probability, which is the number of chance for a particular outcome divided by total number of outcome. Okay, this is the chance and this is probability, and they are related to each other in this form. Okay, that is the probability is equal to the number of chance for a particular outcome and divided by total number of outcome. So यहाँ पर हम लेंगे कि जिस इवेंट की प्रोबेबिलिटी फाइंड करनी है उसका पर्टिकुलर आउटकम का जो भी साइज है या नंबर है डिवाइड करेंगे उसे टोटल नंबर ऑफ आउटकम से. ओके, for example, if we are to calculate the probability of getting a head if one coin is tossed, so if we toss a one coin, the chances are outcomes are heads and tail. Okay, the outcomes are heads and tail. Total outcomes here are 2. So the probability of getting a head will be so first we'll write the number of chances for particular event. That event here is getting a head, so head here is appear only one time, and the total outcome here is 2. So getting a probability of getting a head is 1 by 2. When you divide them, you get 0.5. Okay, so this is how we relate the probability to the chances. Okay, you will understand it better when we will do the questions. Okay, simply you have to understand this formula that probability is equal to number of chances for a particular and particular event or the outcome divided by total number of outcome. Okay, जिस भी केस का मैं प्रोबेबिलिटी फाइंड करना है उसका आउटकम डिवाइड करेंगे टोटल नंबर ऑफ आउटकम से. ओके, दिस इज व्हेन यू फाइंड दिस answer, you will get the probability of that particular event. Okay, next we have event. Event is for any experiment, each outcome or collection of outcome is known as event. Okay, when we perform an experiment, so collection of all the outcome is called its event. Okay, like on tossing a coin, getting a head or a tail is an event. Okay, when one coin is tossed, this getting a head or a tail, both are the events for that experiment. Okay, moving ahead, next we have outcome of an event. So here I have written the outcome of certain event. Suppose if we are to toss one coin, then the outcome will be heads and tail, so the total outcome here are 2. Similarly, tossing of two coin simultaneously means together. Simultaneously means together. Okay, so when we toss two coins simultaneously or together, the outcomes are heads tail, tail head or tail. So the total possible outcome here are 4. Okay, next we have throwing a die. If one die is thrown one time, the possible outcomes are number 1, 2, 3, 4, 5 and 6. So the total outcome here are 6. Similarly, throwing, it should be th, throwing two dice. So this die is the plural of die. In singular it is die, in plural it is dice. Okay, throwing two dice simultaneously will result in total 36 outcome. It change it to black die. Okay, we have two dice, one is red, other one is black. So when you toss two dice together, the outcome can be 1 and 1 on both, one on one on the black one and two on the red one, and so on till 6 on the both one. So total outcome here you can count is 36. Okay, so when one coin is tossed, the outcome is 4. When two coins are tossed, the outcome is are 6. When one die is thrown, the outcome is, sorry, it was 4, and then when one die is thrown, the outcome is 6, and when the two die are thrown simultaneously, the number of outcome is 36. Okay, next we have to understand about the playing cards. So I have written all the information about the playing cards. So a deck of playing card have total 52 cards. So there are total 52 cards in a deck of playing card, and these cards are divided into two colors, which are red and black. That means there are 26 cards of black color and 26 cards of red color. Okay, there are 26 of red and 26 of black. Okay, then we have there are four types of cards in that deck of card, which are club, heart, spade and diamond, and these are the symbol. This is the symbol of club, this is the symbol of heart, symbol of spade and the diamond. So there are total 52 cards, and these two cards are divided into two colors. Cards are divided into two colors, which are red and black. Okay, that means out of these 52, 26 card will be of red color and 26 card will be of red color. Okay, red and black. Out of this, there will be 13 card of heart, which are of red, and other 13 will be of diamond of red color. And in this, black cards are 13 cards are of color club, and the remaining 13 will be of spade. Okay, so these are the basic information about the card. That is, total number of cards in a playing card is 52. There are two colors of card, one is red and other one is black. So there are 26 card of red color, 26 card of black color. Out of those 26, 13 red card of cards are of heart, and the remaining 13 cards are of this diamond. And in the black card, 13 cards are of club and 13 cards are of spade. Okay, and these are the symbol of each one. Okay, then we have, there are 13 cards of each type in a deck of card, which are named as, first card is known as ace, and it is written as A here. Then we have 2, 3, 4, 5, 6, 7, 8, 9, 10, and this 11th one is called joker, 12th one is called queen, and the 13th one is called king. Okay, so these are the labeling of the card. First card is known as ace, this is number 1. Then we have 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 11th is known as joker, 12th as queen, and 13th as the king. Okay, so this is the information that you should know before the start of the exercise 5.3. So this is playing card, and we have discussed the outcome of the event. So these two slides are very important. Okay, so based on this, we have now exercise 5.3. So let's come to the exercise. So before the start of exercise, we'll do one example, which is example number 3 of your NCERT textbook. It says a bag has 4 red balls. There is a bag which contain 4 red balls and 2 yellow balls. Okay, so there are 4 red balls and 2 yellow balls in a bag. The balls are identical in all respect with one another. That means the ball that are inside this bag are identical in shape and size, which means all the balls are of same type. Okay, there is not a case like that one ball is of cricket ball and another one is tennis ball, and there is another ball of which is football. Okay, it's not like that. All the balls are identical, that means they are of same type. Okay, then it say a ball is drawn from the bag without looking into the bag. So one ball is taken out from the bag without looking into the bag. Okay, randomly one ball is taken out. So you have to find what is the probability of getting a red ball. what is the probability of getting a red ball, then you have to ask, is it more or less than getting a yellow ball? Okay, so question is, there is a bag and there are total six balls are inside the bag, out of which four balls are of red color and two balls are of yellow color, and all the balls are of identical in all respect. Okay, that means their shape and size. So let's answer this example number 3. We have total number of balls. First we'll write the total number of balls are 6, and then we have number of red balls is 4 and number of yellow balls is 2. Okay, so we have taken out a ball from the bag and we have to find the probability of getting that ball to be a red ball. Okay, so now we'll write the probability of getting a red ball. So the probability of getting a red ball is equals to, we'll calculate this with the help of the formula which I told earlier, which is total number of balls. So first we'll write the number of red balls divided by total number of balls. Okay, we have used this formula here. This formula, the probability is given by number of chances of particular outcome divided by total number of outcome. So that particular outcome here is red ball, and total number of outcome is given as total 6 ball. Okay, so we are using this formula here. So that is total number of red ball divided by total number of balls. So that will be total number of red ball is given as 4 and total number of balls is 6. When you divide them, this 4 by 6, you will get 2 by 3. So the probability of getting a red ball is 2 by 3. Okay, then you are asked, is it more or less than getting a yellow ball? So you can simply see that as the number of red ball is is more than the number of yellow ball. Therefore the probability of getting a red ball is more than the probability of getting a yellow ball. So I'll write, as the number of red balls is more than the number of yellow balls, so the probability of getting a red ball is more. Okay, you can also see it by, because the probability of getting a yellow ball will be probability of getting a yellow ball will be total number of yellow ball divided by number of yellow ball divided by total number of balls. So number of yellow balls here are 2 and total number of balls is 6. So the answer will be 1 by 3, which is less than this 2 by 3. Okay, so answer for the example 1 is, first we are asked to calculate the probability of red ball, which is 2 by 3, and then we are asked is whether it is more than or less than the probability of getting a yellow ball. So we have got this is more than the probability of getting a yellow ball. Okay, so that's the answer of the example number 3. Now moving ahead to the exercise 5.3. This exercise have total 6 questions. Okay, so first question here is spinning a wheel. Okay, we have to write the outcome you can see in this experiment. First one here is spinning a wheel. Okay, let's write this answer. Okay, when you are asked to write the outcome, okay, here we are not asked to calculate the probability, we have to just write the outcomes. So we have this wheel which have 5 alphabets written on this, which are A, B, C and D. So you have to write the outcomes. Okay, so we'll write the outcomes of spinning a wheel are, so the outcome here will be either A, B, C and D. Okay, when you spin this wheel, this pointer will stop either at alphabet A, B, C or D. So the outcome of this event are A, B, C and D. Okay, but if you're asked to write the number of outcome, the number of outcome here is 4, not 4. Number of outcome here is 5. Okay, when you're asked the number of outcome, you have to count all the alphabet, so that is A, B, C and D. But when you are asked to write the outcome here is only 4, because A is appearing 2 times, but we will count that only 1 time. But if you have to count the numbers, then number will be 5. Okay, so that is the number of outcome here is 5, but the outcome from this spinning a wheel will be 4, which are A, B, C and D. Okay, so we will not write the A twice. Okay, but we will count the A twice when you have to count the number of outcome. Okay, so this is the outcome of spinning a wheel. Then we move to the second part, or the B part, which is tossing 2 coins together. Okay, the outcome of tossing 2 coins together are, like I told you, when 2 coins are tossed simultaneously, the outcomes are heads, 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 tail, tail, heads and tail and tail. Okay, so these are the outcome when the 2 coins are tossed together, which are HH, HT, TH and TT. Okay, so that's the answer of question number 1. Moving to the next one, we have, when a die is thrown, list the outcome of an event of getting, first one is a prime number and then not a prime number. So let's start the answer. This is answer number 2, part A. We have first we'll write the outcome of when a die is thrown. The outcomes of throwing a die are 1, 2, 3, 4, 5 and 6. Okay, so here we are asked, we'll not write the part 1 here, we'll write the part 1 here. Okay, so the outcome of throwing a die are 1, 2, 3, 4, 5 and 6. So we are asked a prime number. So the outcome of prime number is, so first, for writing this, you should know what are the prime number. Prime numbers are the number which are divisible by 1 and by the number itself. Okay, so first prime number that we have is 2, then we have 3, then we have 5. So that there are total 3 prime numbers, which are 2, 3 and 5. And the part B of first one is not a prime number. Now we have to write outcome of not a prime number. So not a prime number are the remaining number, which are 1, 4 and 6. These number are not prime number. Okay, the smallest prime number that we have is 2, and 2 is the only even prime number. The remaining prime numbers will be odd numbers. Okay, now come to the second part. It says a number greater than 5. A number greater than 5. A number greater than 5 is, you can see now, the number greater than 5 is only this 6. So we'll write the outcome is 6. Next one is a number not greater than 5. This is A. Now part B is a number not greater than 5. Now you can see from in these, the number which is not greater than 5 is this only number 6, which is not greater than 5. So all the remaining number, which is number 1 to 5, are the number either equal to 5 or less than 5. So we'll take these 5 numbers. Okay, so these number either less than 5, which are 1 to 4, and equals to 5. We will not take any number which is greater than 5. Okay, so we are asked only the number which are not greater than 5. So those number are number 1, 2, 3, 4 and 5. Okay, so the outcome of the number not greater than 5 is number 1, 2, 3, 4 and 5. Okay, next is the example question number 3. It says find the, we have 3 portion here. First one is probability of the pointer stopping on D in question number 1A. Let's write it answer, which is question answer number 3, part A. You are asked probability of the pointer stopping on D in question number 1A. So first move to the question number 1A. We have spinning a wheel. Total number of outcome here are, so like I said, the outcomes here are A, B, C and D, but total number of outcomes here are 5. So we'll write total number of outcomes here are 5. So we count the A, both the A's. Okay, A, B, C and D, and the number of time D appear is, and number of times D occur is 1. Therefore the probability of pointer stopping on D is equals to number of times D occur, number of times D occur divided by total number of outcomes. Total number of outcomes. So total number of time D appear is 1 and total number of outcome is 5. So the answer is 1 by 5. Okay, this is a part A. Now second one is probability of getting an ace from a well shuffled deck of 52 playing card. Okay, probability of getting an ace. So first we'll write the total number of card, total number of playing card, total number of playing card is 52, and total number of aces in a deck of cards. Total number of aces is 4. One of spade, one ace of spade, one ace of club, one ace of heart, and another one is of diamond. Okay, so total number of playing card is 52 and total number of aces in a deck of card is 4. So or therefore the probability of getting an ace Okay, this question was, we have a deck of 52 playing card and one card is taken out randomly, okay, and we have to find the probability of that card to be an ace. Okay, so for that we have written the number of card, which is 52, total number of aces is 4. Now the probability of getting an ace is given by total number of aces in playing card and total number of cards. So this will be total number of aces is 4 and total number of card is 52, and when you divide them by 4 you will get 1 by 13. So that's the answer for this one, 1 by 13. Okay, moving ahead to the part C. Now you are asked probability of getting a red apple. So we are given this a plate. Within this plate we have total 7 apples, out of which 3 apples are of green color and 4 apples are of red color. Okay, so we have to find probability of getting a red apple if one apple is taken from the plate without looking onto it, that is randomly. Okay, so first we'll write total number of apples which is 7, and then we'll write and number of red apples is 4. Okay, number of red apple here is 4. So now the probability of getting a red apple, therefore the probability of getting a red apple is equals to number of red apple divided by total number of apples, that is number of red apple here is 4 and total number of apple is 7, so probability is 4 by 7. Okay, the probability is 4 by 7. Moving ahead to the next question, we have number 1 to 10 are written on 10 separate slips. Number 1 to 10 are written on the 10 separate slips, one number on one slip, kept in a box and mixed well. So we have 10 slips and number 1 to 10 are written over them, and those slips are put in a box, okay, and they are mixed well. So one slip is chosen from the box without looking into it. What is the probability of getting a number? So we have to find probability of different numbers. So first we'll write the total number of outcomes here. So write answer number 4. Total number of outcome here is 10 because the total number of slips are here 10. So we'll write total number of outcomes is equals to 10. Okay, and the total and the outcomes are number 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So these are the outcome and this is the total number of outcome. So now in the first part we are asked a probability of getting a number 6. Probability of getting a number 6. So how many times on this slip the number 6 has appeared? That number is only one time. Okay, so we'll write number of slips having 6 written on it is only 1. So therefore the probability of getting a number 6 is therefore the probability of getting a number 6 is equals to number of slips having 6 written over it, which is 1, and total number of slips, which is 10. So the probability is 1 by 10. Okay, next part we have getting a number less than 6. So out of these all number, a number less than 6 are number 1 to 5. These numbers are the number which are less than 6. Okay, you are asked the number less than 6. So number 1 to 5 are the number less than 6. The probability is, first you'll write the outcome, the numbers of slip, number of slips having a number less than 6 written on them, that number is 5. Okay, so now the probability of getting a number less than 6 is, therefore the probability of getting a number less than 6 is equals to, so number of slips which have number less than 6 is 5, and total number of slips are 10. So 5 by 10, when you divide them by 5, you will get 1 by 2. Okay, the answer for second part is 1 by 2. Next is getting a number greater than 6. Now the number of greater than 6 are these 4, which are 7, 8, 9 and 10. So similarly we'll write the number of slips having a number more than 6 are equals to total 4 slips. There are 4 slips which have number more than 6. So we'll write therefore the probability of getting a number more than 6 is equals to, that number is 4 divided by total number of slips, which is 10. When you divide them by 2, you will get 2 by 5. Okay, and the last one is getting a one digit number. So out of all these number, we have only one number which has 2 digits, and that number is only 10. Remaining numbers have only 1 digit. So we'll write part 4, number of slips having one digit number written one digit number written on them. Those number of slips is 9. Only 9, number 10 has 2 digits. Okay, therefore the probability of getting one digit number is equals to 9 divided by 10. They cannot not be further divided, so answer will be 9 by 10. So that's the answer on question number 4. Now moving ahead to the next question, we have question number 5. It says, if you have a spinning wheel with green sector, we have 3 green sector and 1 blue sector and 1 red sector. Okay, so there are total 5 sector on that spinning wheel. So you're asked what is the probability of getting a green sector, and then what is the probability of getting a non-blue sector. Okay, so let's write its answer. Number 5, total number of green sector, total number of green sectors is equals to 3. Total number of blue sector is 1, and total number of red sector is also 1. So the total number of sector are total number of sector is 3 plus 1 is 5. Okay, now we are asked what is the probability of getting a green sector. So now we'll write, therefore the probability of getting a green sector is equals to number of green sectors divided by total number of sectors. So number of green sector here is 3 and total number of sector is 5. The probability of getting a green sector is 3 by 5. Okay, next we are also asked probability of getting a non-blue sector. So that is the probability of getting a non-blue sector will be equals to, or will be given by, total number of non-blue sector divided by total number of sectors. So non-blue are, we just remove this blue one. Okay, non-blue are 3 plus 1 is 4. So answer will be 4 by 5. Okay, so that's the probability of getting a non-blue sector, which is 4 by 5. Now moving ahead to the next and the last question of this exercise, it says find the probability of the event given in question number 2, and the question number 2 is here. It says when one die is thrown, list the outcome of then event for getting certain numbers. So let's start this. Answer number 6, part A. Here we'll write the total number of outcome. Total number of outcome will be 6, because in case of one die we have total number of outcome 6, which are number 1, 2, 3, 4, 5 and 6. So in the part 1 we are asked a prime number. So a prime number is, there are prime numbers are here 2, 3 and 5. So now the probability of getting a prime number, the probability of getting a prime number will be number of prime number which are 3 and total number of numbers which are 6, that is total outcome. So answer will be 1 by 2. Part B of this one is non-prime numbers. So we'll write non-prime numbers. Non-prime numbers are number 1, 4 and 6. Hence the probability of getting a non-prime number, the probability of getting a non-prime number will be equals to, again, 3 by 6, and this will be equals to 1 by 2. Okay, so that's the answer of the part 1 of this question. Now moving ahead to the next one, we have a number greater than 5 and a number not greater than 5. Okay, now part second is part 1 of second. We are asked a number greater than 5. So we'll write a number greater than 5 is, we have only one number which is 6. A number greater than 5 is only one number which is 6. So therefore the probability of getting a number which is greater than 5 is, we have only one number and total outcomes are 6. The probability is 1 by 6. Okay, next is part B of this second part. We have a number which is not greater than 5. So write a number not greater than 5. Those numbers are number 1, 2, 3, 4 and 5. Okay, as it says, we have to take a number not greater than 5. Those number are number 1, 2, 3, 4 and 5. It should be either less than 5 or equals to 5. Okay, so the probability will be, therefore the probability of getting a number not greater than 5 equals to, so total number here are 5, and we'll divide them by the total number of outcome which is 6. Hence the probability is 5 by 6. So that's the answer of the part B of second part of question number 6. Okay, with this we have concluded all the 6 question of this exercise, and hence we have completed the exercise 5.3. okay, so now what you have to do is you have to practice all the questions multiple times so that you will be fluent in solving all this question. Okay, so that's all for now. Thanks for joining here.